watching hours of tutorials, saving playlists you never finish, or thinking you need a 3-month paid course before you even start, you're doing it wrong. And no, that's not your fault. Most people are taught coding in the most confusing way possible. So in this video, I'll show you exactly how I'd learn coding fast in 2026. This is a structure anyone can follow, even if you're starting from zero. Now let's get into it. The first and most important step would be choosing a programming language based on the career path I want. This is where most beginners get confused. Coding is not one single thing. Different fields use different languages. For example, data analysis, AI, and machine learning mostly use Python. Web development uses JavaScript along with HTML and CSS. App development might use Java, Kotlin, or Swift. So instead of randomly picking a language, I would first decide the field I want to work in. Now, if I'm completely confused and don't know which field to choose yet, I would go with Python or Java. These two languages are extremely versatile, beginner-friendly, and widely used in the industry. Python is simple and powerful, while Java builds strong fundamentals and object-oriented thinking. Either of them is a safe starting point in 2026. Once I've selected my language, I would not jump into months-long courses. This is a very important rule. Instead, I would watch just one high-quality one-shot tutorial for that language. The purpose of this tutorial is not mastery. The purpose is familiarity. The ideal one-shot tutorial should be around 1 to 4 hours long, and realistically, I can finish it in a single day. During this tutorial, I would not try to memorize everything. I would simply focus on understanding how things work and how code is written. This step gives me a mental map of the language, which is very important before moving forward. After completing the one-shot tutorial, this is where the real learning begins. Instead of watching more tutorials, I would move directly to data structures and algorithms. This is the phase where most people either level up or quit. But in reality, DSA is what teaches you how to think like a programmer. I would start by learning the theory of DSA concepts such as arrays, strings, recursion, searching, sorting, stacks, queues, and basic time complexity. Along with theory, I would always learn the implementation of these concepts in my chosen language. Understanding both theory and implementation is what builds strong foundations. After that, I would begin solving problems. I would start with easy-level questions, especially on platforms like LeetCode. At the beginning, my goal would not be speed or perfection. My goal would be understanding. I would try to solve 2 to 5 problems every day. This number is realistic and powerful if done consistently. Daily problem-solving trains logical reasoning, improves code quality, and removes fear of errors. Slowly, as my confidence grows, I would move from easy problems to medium ones. Hard problems can come later. Consistency matters far more than difficulty. One very important rule I would follow is not buying 2-3-month beginner courses. Most of these courses simply repeat what is already available for free on YouTube. For learning syntax and fundamentals, a one-shot tutorial plus daily DSA practice is more than enough. Courses can be useful later for specialization, but at the beginner stage, they often trap people in tutorial hell, where you keep watching but never build anything. I would avoid that trap completely. After about 1 month of consistent practice, I would reach a stage where I understand a good amount of syntax and have improved logical thinking. This is when I would start building projects, because projects are the real goal of learning to code. I would start with very basic projects available on YouTube, such as small tools, simple applications, or beginner-level websites. The purpose of these projects is not originality at first. The purpose is learning how real code comes together. I would build, break, fix, and improve them. As I grow more confident, I would slowly increase project difficulty. Each project would teach me something new, whether it's handling errors, structuring code, or thinking in terms of real-world problems. Over time, these projects become proof of my skills. By following this structure, I would avoid jumping between tutorials endlessly. I would avoid confusion. I would avoid wasting money early on, and most importantly, I would build a strong problem-solving foundation, which is the backbone of every good programmer. This approach works because it balances 3 things: familiarity with the language, daily logical training, and real-world application through projects. If someone follows this structure with discipline and patience, they can learn coding efficiently, escape tutorial hell, and build real skills that actually matter. After completing this entire structure, I would be fully prepared to move into more advanced concepts and technologies. At this stage, I could confidently choose a specialization like AI and machine learning, natural language processing, web development, backend systems, or even DevOps, depending on the career path I want to follow. The key point is that the structure I explained earlier builds a strong and reliable foundation in coding. It develops logical thinking, problem-solving skills, and real coding confidence, which makes learning advanced technologies much faster and less overwhelming. Instead of struggling, I would now be building on top of a solid base, allowing me to start my journey in the coding world in a far more efficient, structured, and practical way.
Cursor charges €1,700 per month.